हॅलो फ्रेंड्स, वेलकम टू स्वप्ना संस्कुल चॅनल. नमस्कार विद्यार्थी मित्रांनो, स्वागत आहे तुम्हा सर्वांचं स्वप्ना संस्कुल या चॅनलमध्ये. विद्यार्थी मित्रांनो, आज आपण 10th स्टँडर्ड सायन्स अँड टेक्नॉलॉजी पार्ट 1चं 7th लेसन लेन्सेस याची एक्सरसाइज बघत आहोत. तर चला आपल्या व्हिडिओला सुरुवात करूया. क्वेश्चन 1. मॅच द कॉलम्स इन द फॉलोइंग टेबल अँड एक्सप्लेन देम. कॉलम फर्स्ट, कॉलम सेकंड अँड कॉलम थर्ड. दिस इज द क्वेश्चन. हा प्रश्न आहे. उत्तर पाहूया. कॉलम 1. फार साइटेडनेस. Far away object can be seen clearly and convex lens. Second, presbyopia, problem of old age, bifocal lens. आणि तिसरा आहे near sightedness, nearby object can be seen clearly, concave lens. First, far sightedness. Hypermetropia or far sightedness is the defect of vision in which a human eye can see distant object clearly but is unable to see nearby object clearly. In this case, the image of a nearby object would fall behind the retina instead of on the retina. Possible reasons for hypermetropia. First, curvature of the cornea and the eye lens decreases, hence the converging power of the eye lens becomes less. Second, the distance between the eye lens and retina decreases relative to the normal eye, and the focal length of the eye lens can become very large due to the flattening of the eyeball. So this is how it looks. असं दिसतं. हे बघा, हे पहिले फार अवे ऑब्जेक्ट कॅन बी क्लिअरली सीन. हे सेकंड आहे हायपरमेट्रोपिया आय आणि हे तिसरं आहे करेक्शन ऑफ फार साइटेडनेस आईज. presbyopia. Presbyopia is the defect of vision in which aged people find it difficult to see nearby objects comfortably and clearly without spectacles. Reasons of presbyopia. The power of accommodation of eye usually decreases with aging. The muscles near the eye lens lose their ability to change the focal length of the lens. Therefore, the near point of the eye lens shifts rather from the eye. This defect is corrected using a convex lens of appropriate power. The lens converges light rays before they fall on the eye lens such that the actions of the eye lens forms the image of retina. Nearsightedness. Myopia or nearsightedness is the defect of vision in which a human eye can see nearby objects distinctly, but is unable to see distant objects clearly as they appear is indistinct. In this case, the image of a distant object is formed in front of the retina instead of on the retina. Possible reasons for myopia. First, the curvature of the cornea and the eye lens increases. The muscle near the lens cannot relax so that the converging power of the lens remain large. Second, the distance between the eye lens and the retina increases as the eyeball elongates. Myopia is corrected using a suitable concave lens. The light rays are diverged by the cornea lens before they strike the eye lines. The concave lens of proper focal length is chosen to produce the required divergence. Hence, after the converging action of the eye lens, the image is formed on the retina. Question 2. Draw a figure explaining various terms related to a lens. Answer. First, center of curvature means C. The center of the spheres whose parts from the surface of a lens are called the center of curvature of the lens. A lens has two centers of curvature C1 and C2 for its two spherical surfaces. Second, radii of curvature means R1, R2. The radii of the spheres whose parts from surfaces of a lens are called the radii of curvature of the lens. Third, principal axis. The imaginary straight line passing through the two centers of curvature of a lens is called the principal axis of the lens. Fourth, optical center O. The point inside a lens on the principal axis through which light rays passes without changing their path is called the optical center O of the lens. Fifth, principal focus F. When light rays parallel to the principal axis are incident on a convex lens, they converge at a point on the principal axis. This point is called the principal focus F of the convex lens. Light rays traveling parallel to the principal axis of a concave lens diverge after refraction in such a way that they appear to be coming out of a point on the principal axis. This point is called the principal focus of the concave lens. A lens has two principal foci for f1 and f2. 6. Focal length f. The distance between the optical center and the principal focus of a lens is called the focal length, small f of the lens. So हे बघा, हे लक्षात ठेवा की फोकल लेंथ जे असते त्याला स्मॉल एफने दर्शवतात आणि जो फोकस लाईन असते ती मोठ्या एफने. सो C1 C2 म्हणजे सेंटर ऑफ कर्वेचर आणि R1 R2 म्हणजे रॅडी ऑफ कर्वेचर. O ऑप्टिकल सेंटर. द क्रॉस सेक्शन ऑफ convex and concave lenses are shown in part A and B of figure 7.4. The surface marked as 1 is part of sphere S1 while the surface marked as 2 is part of sphere S2. P1, P2, P3. Incident rays of light and Q1, Q2, Q3 is refracted rays of light. O optical center. F1, F2 principal foci of the lens. F focal length of the lens. सो बघा हे इन्सिडेंट रेज आहेत लाईटचे. हा प्रिन्सिपल ॲक्सिस आहे. हे रिफ्रॅक्टेड लाईट्स इथे जमा होतात आणि ते रिफ्रॅक्ट होतात पुढे. हे कॉन्वेक्स लेन्स झाली आणि ही झाली कॉन्केव्ह लेन्स. सो इथे ही जी आहे ही इन्सिडेंट रेज आहे, ही प्रिन्सिपल ॲक्सिस आहे आणि हा जो झाला हा रिफ्रॅक्टेड लाईट झाला, रिफ्रॅक्टेड रे. Question 3. At which position will you keep an object in front of a convex lens so as to get a real image of the same size as the object? Draw a figure. Answer. At 2f1, this is a convex lens, this is principal axis. O इथे ऑप्टिकल सेंटर आहे. F1 F2 प्रिन्सिपल फोसी आहे. स्मॉल एफ फोकल लेंथ आहे. AB हा जो AB आहे हे ऑब्जेक्ट आहे. परत A' B' हे इमेज आहे. U हा ऑब्जेक्ट डिस्टन्स आहे आणि अशा प्रकारे आपलं हे आन्सर आहे. क्वेश्चन 4. गिव्ह सायंटिफिक रिझन्स. A. A simple microscope is used for watch repairs. Answer. When an object is placed within the focal length of a magnifying glass or simple microscope, म्हणजेच convex lens, its larger and erect image is obtained on the same side of the lens as that of the object. By adjusting the distance between the object and the lens, the image can be obtained at the minimum distance of distinct vision. Thus, a watch repair can see the minute parts of a watch more clearly with the aid of a magnifying glass, a simple microscope, than with the naked eye, without any stress on the eye. Hence, watch repairs use a magnifying glass, a simple microscope, while repairing the watches. B. One can sense colors only in bright light. Answer. First, the retina in the eye is made of many light-sensitive cells. The rod-shaped cells respond to the intensity of light, while the cone-shaped cells J respond to various colors. Second, the cone-shaped cells do not respond to faint light. They function only in bright light. Hence, one can sense colors only in bright light. We cannot clearly see an object kept at a distance less than 25 cm from the eye. Answer. When we try to see a nearby object, the eye lens becomes more rounded and its focal length decreases. Then a clear image of an object is formed on the retina of the eye. Second, the focal length of the eye lens cannot be decreased beyond some limit. Therefore, we cannot clearly see an object kept at a distance less than 25 cm from the eye. Question 5. Explain the working of an astronomical telescope using refraction of light. Answer. Construction of a refracting telescope. It consists of two convex lenses called the objective lens, direct towards the object, and the eyepiece, directed towards the eye. The focal length and diameter of the objective lens are respectively greater than the focal length and diameter of the eyepiece. The objective lens is fitted at one end of a long metal tube. A metal tube with smaller diameter is fitted in the metal tube and the eyepiece is fitted at the outer end of the smaller tube. With the help of a screw, it is possible to change the distance between the eyepiece and the objective lens by sliding the tube fitted with the eyepiece. The principal axis was of the objective lens and the eyepiece are along the same line. A telescope is usually mounted on a stand. So ही ऑब्जेक्टिव्ह लेन्स आहे, हा आयपीस आहे. इथे आपल्याला अशा प्रकारे आकृती दाखवली आहे. Working. When the objective lens is pointed towards the distant object or to be observed, the rays of light from the distant object, which are almost parallel to each other, passes through the objective lens. The objective lens collects maximum amount of light as it large in size. It forms a real inverted and diminished image in the focal plane of the objective lens. Now the position of the eyepiece is adjusted such that this image falls just within the focal length of the eyepiece and serves as the object from the eyepiece, which works as a simple microscope. The final image is highly magnified, virtual, on the same side as the objective and inverted with respect to the original object. The final image can be observed by keeping the eye closed to the eyepiece. If the image formed by the objective lens lies on the focal plane of the eyepiece, the final image is formed at infinity. Question 6. Distinguish between the following. A. Farsightedness, hypermetropia and nearsightedness, myopia. Farsightedness. In hypermetropia, a human eye can see distant distinctly but is unable to see clearly objects clearly. In this case, the image of a nearby object would be formed behind the retina. This defect can be corrected using a convex lens appropriate power. Nearsightedness. In myopia, a human can see near objects distinctly, but is unable to see distant object clearly. And in this case, the image of a distant object is formed in front of the retina. This defect can be corrected using a concave lens of appropriate power. B. Concave lens and convex lens. Concave lens. Concave lens has its surface curved inwards. It is thicker at the edges than in the middle. It can form only a virtual image and it can form only a diminished image. Convex lens. A convex lens has its surface puffed up outwards. It is thicker in the middle than at the edges. It can form a real image as well as virtual image. It can form a magnified, diminished or the same sized image relative to the object depending on the position of the object. Question 7. What is the function of the iris and the muscles connected to the lens in the human eye? Answer. When the incident light is very bright, the muscle of the iris stretch to reduce the size of pupil. When the incident light is dim, the muscle of the iris relaxes to increase the size of the pupil. Thus, the iris controls the size of the pupil and thereby regulates the amount of the light entering the eye. Figure 7.26. So, this is the figure of eyeball. When the distant object is to be observed, the ciliary muscle relaxes so that the eye lens becomes flat. This increases of the focal length of the lens. Therefore, a sharp image of distant object is formed on the retina. Thus, we can see a distant object clearly. When an object closer to the eye is to be observed, the ciliary muscles contract, increasing the curvature of the eye lens. The eye lens therefore becomes rounded. This decreases the focal length of the lens. Therefore, a sharp image of nearby object is formed on the retina. Thus, we can see a nearby object clearly. हे बघा अशा प्रकारे आपण ही इमेज बघू शकतो. Question 8. Solve the following example. First question है, doctor has prescribed a lens having a power of plus 1.5D. What will be the focal length of the lens and what is the type of the lens and what must be the defect of vision? हे लक्षात ठेवा की जर प्लस 1.5 असेल किंवा प्लस काही संख्या असेल तर हा कॉन्वेक्स लेन्स आहे. जर मायनस असेल तर कॉन्केव लेन्स आहे. सोल्युशन. डाटा P is equal to plus 1.5D and F is equal to what? So focal length of the lens is equal to F is equal to 1 upon P is equal to 1 upon 1.5D. So 10 upon 15 meter is equal to 0.6667 meter is equal to 0.67 meter. P is positive. This shows that the lens is convex. The defect of vision is farsightedness, means hypermetropia. Second, 5 centimeter high object is placed at the distance of 25 centimeter from a converging lens of a focal length of 10 centimeter. Determine the position, size and the type of image. Solution. Data. Converging lens म्हणजेच f is equal to 10 centimeter, u is equal to 25 centimeter, h1 is equal to 5 centimeter, v is equal to what and h2 is equal to what. So first 1 upon f is equal to 1 upon v minus 1 upon u. So 1 upon v is equal to 1 upon f plus 1 upon u. तर 1 upon v बरोबर एक 1 upon 10 centimeter plus 1 upon minus 25 centimeter is equal to 1 upon 10 centimeter minus 1 upon 25 centimeter. That's why 5 minus 2 upon 50 centimeter is equal to 3 upon 50 centimeter. So image distance means v is equal to 50 upon 3 centimeter. So 67.67 centimeter is equal to 67.7 centimeter. And about height म्हणजे आता बघा हाईट काढायची तर h2 upon h1 is equal to v upon u. So h2 is equal to v upon u into h1. h2 is equal to 5 upon 3 centimeter upon 25 centimeter into 5 centimeter. म्हणजेच 10 centimeter upon 3 centimeter is equal to 50 into 5 centimeter upon 25 into 3 centimeter is equal to 333 centimeter म्हणजेच 3.3 centimeter. Third, 3 lenses having power 2, 2.5 and 1.7D are kept touching in a row. What is the total power of the lens combination? Solution. Data. P1 is equal to 2D, P2 is equal to 2.5D, P3 is equal to 1.7D. So P is equal to what? Total power of the lens combination म्हणजेच P is equal to P1 plus P2 plus P3 म्हणजेच 2D plus 2.5D plus 1.7D म्हणजेच 6.2D. Fourth, an object kept from 60 centimeter from a lens gives a virtual image 20 centimeter in front of the lens. What is the focal length of the lens? It is converging lens or diverging lens. Solution. Data. U is equal to minus 60 centimeter, V is equal to minus 20 centimeter, F is equal to what? 1 upon f is equal to 1 upon v minus 1 upon u म्हणजेच 1 upon minus 20 centimeter minus 1 upon minus 60 centimeter. So 1 in bracket 1 upon 20 centimeter minus 1 upon 60 centimeter is equal to minus in bracket 3 minus 1 upon 60 centimeter. So minus 2 upon 60 centimeter is equal to minus 1 upon 30 centimeter. Thus the focal length of the lens f is equal to minus 30 centimeter. As f is negative, it is a diverging lens. Thank you so much for watching the video. विद्यार्थी मित्रांनो, जर तुम्हाला या धड्यामध्ये काही अडचण असेल, काही प्रश्न विचारायचे असतील तर या व्हिडिओच्या कमेंटमध्ये आम्हाला नक्की विचारा. आम्ही तुम्हाला त्याची उत्तरे पोहोचवण्याचा प्रयत्न करू. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, चॅनलला सबस्क्राईब करा. धन्यवाद.